Hi there. So in this video, we're going to be talking about scientific notation. So sometimes in science, we deal with really, really small numbers or really, really big numbers. And so we need kind of a convenient way to express those numbers. And what we'll use is what we call scientific notation. And it's a shorthand method for describing those really, really big numbers or really, really small numbers. So how about some examples of what we're talking about? So the number of carbon atoms in a 1 carat diamond, okay, is around 10 billion trillion carbon atoms. So carbon atoms must be really, really small since there's so many of them packed into a 1 carat diamond. Okay, so 10 billion trillion. So that's 10 and a whole mess of zeros after it, right? And so that's an example of a really big number. We can go the other way and think about a really, really small number. So here's the diameter of the nucleus of a uranium atom. Okay, so uranium on the periodic table, number 92. Its nucleus, the part of that atom where all of the protons and neutrons are packed together, the diameter of that is a millionth of a billionth of a meter. So, we know that a meter is about around 3 feet. Okay, so take 3 feet, take 3 feet, take a yardstick or a meter stick, divide that up into a billion pieces, then take one of those billion pieces and divide it up into a million more pieces. One of those million pieces of that billionth, right? So 1/1,000,000th of a billionth is the size of that nucleus. Okay, so something very, very small. So a whole bunch of zeros before we get to the first non-zero. So that becomes kind of inconvenient to have to write out all of those zeros either at the beginning or the end of a number to describe the magnitude of that number, how far away, how much smaller it is than 1, or how much bigger it is than 1. And so we can use scientific notation as a way to help shorthand that idea of magnitude. And so the way that we'll describe scientific notation, or the format that we'll use for scientific notation, is always the same. It's this format here where you've got a times 10 raised to the b power, okay? And so that a number, in order to be proper scientific notation, that a number has to be something that is greater than or equal to 1, but less than 10, okay? So it's got to be something between 1 and 10, but it can be exactly 1, but it's got to be less than 10, right? And then, so that's this number at the beginning, this a number, and then this b, the exponent, is basically telling us how much bigger than 1 is that number, or how much smaller than 1 is that number. Okay, and so b is going to describe to us how many places we had to move our decimal point to get our number between 1 and 10. And so that b exponent can either have a positive, it can either be positive or negative, depending on which way we're moving that decimal. Okay, so let's try an example. So let's try 105. Okay, so let's try to turn that number into scientific notation. Now, 105 isn't really that big of a number, so the scientific notation version of 105 is actually going to look more inconvenient than the number itself. But for the sake of argument, let's think about how we would turn 105 into scientific notation. Well, the first thing to ask ourselves is, where is the decimal point in this number? Well, it's not written explicitly, but it's there implicitly. We know that there's a decimal point right there. Okay, so it's 105 point, right? There's a decimal at the end of that number. And so now what we need to think about is, okay, how can we move that number to get it to be, or how can we move that decimal point to get the number to look like something that is between, or that's greater than or equal to 1, but less than 10? Well, if we slide the decimal point one place in this direction, okay, now we've got a number that would be 10.5. Okay, so that's a little bit greater than 10, so that's not going to work for us. So we can move it one more decimal place, and now we've got a number that is 1.05, which satisfies our criteria. It's greater than or equal to 1, it's less than 10. Okay, so let's write that number, 1.05. Okay, and so now I can write that times 10 raised to what power do I want to raise it to? Well, I want to raise it to the second power because I moved this decimal point two places. I slid the decimal point 2 times to make this number, this A number, be between 1 and 10. So I'm going to make it times 10 to the second power. And so the question is, do I want that to be a positive 2 or do I want it to be a negative 2? Well, the rule of this says that a negative exponent indicates that we had to move the decimal to the right to get our number into scientific notation. And a positive exponent indicates that we move the decimal to the left to get our number into scientific notation. And that's what happened here. We moved our decimal 2 places to the left to get it into scientific notation. So we would want this exponent to be a positive 2. And if we think about that, what does that mean exactly, right? So this is our number in scientific notation. So 105 written in scientific notation is 1.05 times 10 to the second power. Well, what does that mean? We've basically taken this number and turned it into a math problem, right? So we can kind of solve that math problem to see, can we get it back into that original number? Well, 10 squared is 100, right? So this scientific notation says 1.05 times 100. And if we did that math, of course, we'd end up with 105. Okay, so 1.05 times 10 to the second power is 105 written in this scientific notation. Okay, so let me try another one that's going to end up looking kind of similar. So I'm going to start with the number 0.0105. Okay, 0.0105. So how do I get this number to look like it's between 1 and 10? Well, what I can do is start to slide that decimal. And if I need to slide it to get it to be between 1 and 10, I'm going to have to make that number bigger, right? So I'm going to start sliding the decimal to the right. If I slide the decimal place 1 place to the right, now the number that I would have is 0.105, okay, which is still a little bit less than 1. But if I slide it 1 more place, now the number that I have, is 1.05, right? So I can write 1.05. It's greater than 1, or greater than or equal to 1. It's less than 10. And I can multiply that by 10. And then what power am I going to raise it to? Well, it's going to be the second because I moved the decimal 2 places. And so now the question is, should that 2 power, should it be positive or negative? Well, this time I slid the decimal to the right, right? I slid it 2 places to the right. And so my rule says that if I slide the decimal to the right, that power should be negative. So this number, written in scientific notation, would be 1.05 times 10 to the minus 2 power. Right? And so again, what does that mean? We've taken this number and we've turned it into a math problem, right? So what is 10 raised to the negative 2 power? Well, it's 1 over 10 to the 2 power, right? So this number is, or this, quote unquote math problem is 1.05 times 1 over 100, right? Because 1 over 10 squared is 100, so 1 over 100, okay? And so I could write that as 1.05 divided by 100. And what is that going to equal? Well, it's going to equal 0.0105, okay? So we've got 2 different numbers that look really similar once we get them into scientific notation, right? 1.05 times 10 to the positive 2 gives us 105. 1.05 times 10 to the negative 2 gives us 0.0105. So negative exponents mean that we have a number that's less than 1. Okay? Positive exponents mean we've got a number that's greater than 1. Okay? All right, so that's the idea. Let's try a couple more example problems. So let me just erase this real quick. Okay. So here's 4 more example problems, and let's work through each of these. Okay, so this first number here, right? So this number is less than 1, so we're probably going to end up with um, the number being in scientific notation. It's going to have a power that's a negative number, right? Because the negative powers represent a number that's less than 1. And so how do we get there? Well, we've got to take this number and we've got to start moving that decimal point to get us to a number that is greater than or equal to 1 and less than 10. And so what I can do is start to move that decimal, and I'm going to move it 1, 2, 3, 4, 5, 6 places. Okay, if I move that decimal place 6 places to the right, now I've got a number that is 8.4 times 10, and that's going to be raised to the 6th power because I moved the decimal 1, 2, 3, 4, 5, 6 places, and it's going to be to the negative 6, right? Because I moved that decimal to the right. Okay. So 8.4 times 10 to the minus 6. Okay. Well, how about this one? I've got 485,000. So in this one, in order to get this number to be greater than or equal to 1 and less than 10, I'm going to need to slide that decimal place to the left this time, right? So my initial decimal point is here, right? And I'm going to start sliding it 1, 2, 3, 4, 5 places. If I slide it 5 places to the left, now I've got 4.85, okay? So 4.85 times 10, and that'll be raised to the 5th power. I moved it 5 places, and I moved it to the left, okay? So that's going to be a positive exponent. So 4.85 times 10 to the 5th. This number here is another number that's much bigger than 1, so we would expect there to be a positive exponent. Okay, let me try switching colors to something a little brighter, maybe. Okay, so a number that's much bigger to 1. So where's the decimal point? Well, it's right here at the end of that number. Okay, and so I want to start sliding that decimal point until I get to a number that is greater than or equal to 1, less than 10. Okay, so I'm going to start moving this 1, 2, 3, 4, 5, 6, 7, 8 places. Okay, so if I move that number 8 places to the left, I'm going to end up with this number, 1.604 times 10 to the 8, right? I move the decimal 1, 2, 3, 4, 5, 6, 7, 8 places, and that is going to be a positive 8 because I slid the decimal to the left. And I can check myself, right? So the original number was greater than 1. Okay, it wasn't a fraction, so I'm going to have a positive exponent there. Okay, and finally, this last one, we see our decimal point here. This number is less than 1, so that means I'm going to need to slide the decimal to the right. It means I'm going to have a negative exponent. Okay, so in order to get this decimal, or in order to get this number to be between 1 and 10, I'm going to slide it 1, 2, 3 places. Okay, 3 places to the right. And what I'll end up with is 2.10 times 10 to the negative 3rd. Okay, it's a 3rd power because I slid the decimal 3 places, and it's a negative 3 because I slid that decimal to the right. Okay, well, this is scientific notation, and probably this is review from some earlier class, but hopefully this helped. There's some practice problems that we can do to get more practice with this, but feel free to come back to this to get a refresher on scientific notation anytime. All right, until next time.